presentation on video use in the classroom and how it could be applied to a specific lesson. So, first we're going to identify a lesson that I have taught or will teach, and in this case it's both. So before I give a Chapter 2 test on polynomials, I leave a full class review. As you can see, there are applications and word problems right here, and these are the style of questions that I'm going to give on the exam. However, I've also provided differentiated skill-based work at the basic and medium level for kids who are struggling. So I provide a full class period for kids to work, and then I post an answer key to our online database, so that way students can check their work as they go, and if they don't finish in class, they have that resource at home. So the objectives are for students to master skills that have not already been mastered, to make sure that previously mastered skills are retained, to make connections between discrete skills so that students start to see math as a system of knowledge as opposed to a series of different procedures, and lastly, to start applying skill-based knowledge to more advanced level problems, real-world problems, word problems, etc. So this is the lesson that I'm going to start integrating video into. So how am I going to do that? Well, currently students receive that worked out answer key and it has teacher handwriting on it, but the limitations of this are that it's static, it doesn't move, and it's frankly not very engaging because it doesn't move. There are no explanations or verbal support. It's just step-by-step worked out solutions. There's handwriting issues. Some students have difficulty reading handwriting that's not Times New Roman text, and for feasibility, that would be virtually impossible to do on a class-wide basis. And last but not least, it's most likely to benefit students who've already achieved a certain level of mastery, and for the kids who are still struggling, I want to be able to provide more support. So my question is, what if students had access to a video in which the teacher completes and narrates the answer key? Would that provide more support? So let's look to the research. How can videos support student learning? Well, according to Smaldino, this is our textbook, video can enhance student learning across 4 different domains. The first is cognitive domain because color, sound, and motion can enhance cognition. And that's a little bit what I was referring to before, saying that the previous answer key was pretty static. So that motion might be able to help students make connections. There's the affective domain and the appeal of emotion. In a video tutorial, this probably isn't going to be as dramatic as, say, watching a documentary about a really intense historical event, but if I'm making the video, there's still an appeal of emotion because I'm their teacher and they have a relationship to me. So this still does apply. For the psychomotor domain, it allows demonstrations or processes to be shown, and we can slow down, speed up, or freeze time. This is a really, really, really crucial piece here because students can rewatch, watch, or pause the video as they choose. So that's a huge element in my vision. And last but not least, the interpersonal domain, it can provide a catalyst for discussion. Probably not a huge element in my vision for a tutorial. However, students, of course, could discuss the video and work together to problem solve. So to move away from general video use and to kind of hone in on a more specific use of video, I want to discuss flipping a classroom. So a flipped classroom uses videos outside the walls of the classroom. So students can watch teacher lectures at home that prepare them for class. So in this case, we're not really preparing them for class as much as an exam, but since the exam is part of class, I think it's still relevant. So we're going to discuss some of the benefits of a flipped classroom and some of the limitations or misconceptions so that it helps me create a video that will be ultimately useful. So according to Bergman and Sams, who are pretty much the pioneers of flipping a class, there are a lot of advantages to a flipped class, including helping struggling students, providing real differentiation, allowing students to pause or rewind their teacher, okay, and that's differentiation of pacing, creating opportunities for parent involvement. Parents now have access at home to information that's happening in class. Student to teacher interaction is freed up because the lectures aren't happening in class, the practice is happening in class, so that completely changes how much students and teachers can talk to one another. Same thing for student to student. If they're doing their practice in class as opposed to at home, then they can work together more frequently. Of course, this changes classroom management because the activities in class are changing, therefore the way in which you manage your classroom is going to change. And it creates transparency for your classroom. So these are some reasons why you might flip a class. But here are some reasons why you might not want to flip a class. Firstly, because it's innovative and cutting edge. Frankly, you don't even need the latest technology to do it. It's not going to make your job easier. And lastly, don't do this because it's going to create a modern classroom. Pedagogy should drive technology, but not the other way around. So these are some important things that I keep in mind when I decide, is this an appropriate time to use video? So this is the main question. Why should I use the video for this particular lesson? Well, reason number one, it provides personalized support. So both the content and the pacing can be tailored to the student. So students can skip through questions that they've mastered and skip ahead to questions that they still need help on. Students can watch or rewatch as many times as they need. And I think that this really meets every student at the place that they're currently at. Reason number two, it gives students flexibility and control. So students can watch the tutorial when and where it's convenient for them. If a student has a question at home, the student does not need to wait until the next class period to receive help. And this is huge for a lot of my students who struggle with anxiety. So that way they feel like they have all the tools they need at home to be successful. It maximizes content coverage. So by making this video accessible at home, we don't lose a class period to reviewing a study guide. If I gave a class period to do the study guide plus a class period to go over the study guide, we're really behind. This really streamlines our ability to cover a lot of content. And if you maximize this, or if you repeat this multiple times throughout the year for each unit you cover, then you're basically gaining an additional class period per unit. So that's really fantastic. Last but not least, it uses direct instruction where it's most appropriate. So during practice or review or remediation, I believe that direct instruction can be used to fill in gaps and correct misunderstandings. It can also be used to prompt students on information that they may have forgotten. By contrast, I believe that new material is best introduced with student-centered investigations, which encourages students to construct their own knowledge. So this piece of the unit, the fact that it's coming at the end, the fact that we've already done more student-centered investigations, makes me think that this is a good time to use a video tutorial, since direct instruction would be appropriate. So incorporating direct instruction as a remediation technique aligns best with my personal teaching philosophy. So here's my plan. We're going to use Xiteboard, which is an interactive whiteboard that can be accessed from an iPad and a computer simultaneously. I'm going to upload images of each question to the whiteboard so that students can see the question and the answer right next to each other. And I'm going to record a video. You'll see my handwriting in motion, and you'll also hear audio support. So here are some references, and we'll get started with the video in just a moment. Hi everyone, it is Ms. Martins, and I am going to review a little bit of the material from section 2.1 as promised. And as you can see, I've put the 4 questions that I assigned from this section right into this document so that way I can work on this page. And I'm going to get started with question 39. 39 is an error analysis question, so we have to figure out 2 things. 1, what is the correct answer? And 2, what was the mistake that was made? In these kinds of problems, the mistakes aren't random. The mistakes are actually quite intentional, and they're common. So we want to try to get into the head of the person who wrote this and figure out what were they thinking, what was the logic behind this mistake, what was the method to the madness. So I'm going to ask you to pause for a moment if you don't already have the answer in your head, and I want you to try to think of what you would answer this question to be, and you can resume the video when you're ready. So as you can see in this problem, we've got an exponent of 2 and an exponent of 4, and we have a base, -3, on both pieces of that left-hand side. So we know that when we have the same base, we're just going to add the exponents. So 2 plus 4 does equal 6. So as you can see, 6 is correct. That's not an issue. The issue is in the bases. So hopefully when you paused and thought about how you would answer this question, you notice that we don't actually multiply the bases when we multiply two powers with the same base. So the rule, if you refer back to your textbook, is that a to the n times a to the m is equal to a to the n plus m. In other words, we add the exponents and keep the base. So, with that said, using this rule, we should see that the answer would actually be negative 3 to the 6th power. Okay, and to show you why that works, not just what the rule is, but why it makes sense, well, negative 3 squared can be understood as negative 3 times negative 3. And negative 3 to the 4th power is negative 3 times itself 4 times. So I'm writing that out right now. And you can see that we have a multiplication sentence, negative 3 times itself 6 times. And if we were to condense this into one expression using an exponent, we would get right back to negative 3, all raised to the 6th power. Okay? So that's part 1. Part 1 is figuring out what should the correct answer be. Part 2 of this question is to figure out what were they thinking. So if you haven't yet already answered that to yourself, pause the video, and when you're ready, you can resume. So here's what I think the author of this sentence was actually thinking. They were saying, well, here's a power, negative 3 to the 2nd power, and we're multiplying it by another power. So to me, it seems like the author was confusing multiplying two powers with multiplying two bases. We are multiplying two powers, but we're not multiplying the bases, we're keeping the bases. So that's how I would describe the mistake. It seems like the author confused multiplying powers with multiplying bases. And I'm just using shorthand to try to save time, okay? And if it were a test, I would write that in a complete sentence. It seems like the author confused multiplying powers with multiplying bases. When you multiply two powers, you add the exponents and keep the base. You never, ever, ever multiply the two bases together, which is what the author was thinking. So that's really what I would be looking for in a question like number 39. And as you can see, we're applying what we learned about our exponent properties and asking to think a little bit deeper by analyzing someone else's work. So let's continue on to question 41. We'll use exponent properties in another way. So question 41 is a little bit different. This question is asking us to rewrite an expression in terms of x and x over 2. So x over here, I'll use blue. X over here refers to the radius. And I'll use another color, how about red? And here, x over 2 refers to the height. So now I'm going to plug that in to this expression. And where I used to have r, I'm going to plug in x. I'm going to square it just like I used to square r. And I'm going to multiply by h. H is going to be x over 2. So all I did right now is I substituted. Okay, so right now is where the exponent work comes in. So I want you to pause the video and I want you to try to simplify this as much as possible before you restart the video and you can check your work. So go ahead and pause it. When you're ready, we'll resume. So continuing on, we've got volume equals pi. Now I'm going to treat these all like like fractions. So that way we can see exactly what we're doing. And we know that we can multiply fractions across. And we're going to go ahead and simplify using those rules. So the volume equals, we've got x squared times x, and there's a secret little 1 up there. So we know that when we're multiplying two powers with the same base, we just add the exponents. So our numerator is going to look like pi times x cubed. Okay, and then our denominator is going to be 1 times 2, which is just 2. And this should be the final answer. Okay, so hopefully that's what you got when you paused the video. Continuing on to number 44. This one's a different kind of question. We need to basically go in reverse. This right here is like the answer, and this is the question. And we're trying to figure out what question would yield this answer.
Okay, so we're going to go piece by piece. That's the best strategy, to focus on the numbers separately and then each variable separately. So let's start with just isolating the 3 and the 12, which are the constants. Okay, so we effectively want to know what would have to be in the denominator in order for those constants to simplify to 3. So one way of expressing that is 3 equals 12 over what? Now I already have an x and a y, so it probably makes sense to use a as my variable. Okay, so I need to isolate a. I'll multiply by a on both sides. Okay, so I'm going to get 3a equals 12. To get a all by itself, I'll divide by 3. And I think I'm getting that a is 4, which makes sense because 12 divided by 4 is in fact 3. So we've figured out one piece of this denominator. I'm going to use another color. How about red? Okay, and we're going to focus on our x variable. So we have x cubed, and I'll put that right here. X cubed equals x squared over x to what power? Okay, and we know that when we divide, we are going to be subtracting the exponents. So in other words, 2 minus what equals 3? If you're not sure where those numbers came from, I'm going to highlight them right here. Here's 2, here's my box, and here's my 3. Okay, so that's how I knew what numbers to put in my sentence. Okay, so 2 minus what number is 3, and I'll use b as my variable here. So we're going to solve for b. We'll subtract 2 on both sides. Okay, I think we're going to get negative b equals 1, which means that b equals negative 1. And that refers to the exponent. So just remember, what we're solving for is this exponent here. So that's going to mean that x is raised to the negative 1 power. Now, at this point, you've seen me do it for constants, you've seen me do it for variables. Go ahead and pause the video, try to do y by yourself. And then when you're ready, resume the video and I'll show you and confirm your answer. So hopefully you've paused it. We're going to continue on and we're going to show how we can figure out y. So we've got y to the second power equals y to the fifth over what? So we're going to say y to what power? So just like I did before, 5 minus what? Oops, this is kind of getting a little bit sneaky. There we go. 5 minus what equals 2? So we'll call this c. Okay, that's our third variable. Let's subtract 5 on both sides. We get negative c equals negative 3. Divide by negative 1, divide by negative 1, and I think we're going to get c equals positive 3. So we have to put all this together to figure out what our final answer is going to be. And I'll put my final answer in purple so that it stands out. Okay, but my constant is going to be 4. Okay, that's from right over here. My exponent for my x term is going to be negative 1. So I have x to the negative 1. And then my exponent for the y variable is going to be 3. So y to the third. Okay, so I think this is going to be your final answer for number 44. Now, in your textbook, they rewrote this as over x to the first power. That's totally fine, but we haven't really dealt with complex numbers, complex fractions. So with that said, it's okay if you want to leave your answer like this. I will totally accept it. So we're going to go on to the very last bit. And this is a word problem, so we haven't done a ton of word problems, so this will be a great chance for you to apply what we've learned. And without reading everything, it says right here, calculate the volume of each ocean by multiplying, and I'm going to scoot to the right, by multiplying the surface area of each ocean by its average depth. That's really the key point here because that tells us exactly what we're responsible for doing. Okay, so I'm going to do 1 or 2 of these, and once you get the hang of it, you should be able to do the rest. And you already have a worked out answer key posted online, so once you see the technique, you're just changing the numbers, and it should all make sense from there. But we're going to start with just looking at the Pacific. So one thing I like to do when I solve problems is keep everything organized so that I can follow my work. And remember, when I'm grading your work, the easier it is for me to read, the more partial credit I can give you. So do keep that in mind. So we're going to start by taking the surface area, which is 1.56 times 10 to the 14th power. And we are going to multiply that by 4.03 times 10 to the third power. And the first thing that we're going to do is consider the commutative property. And the commutative property states that in a multiplication sentence, we can rewrite the order to be more beneficial to us. So I'm going to start by just taking my constant terms, which are right over here. Okay, there's no exponents written at all. I'm just going to put those next to each other. 5, 6 times 4.03. And then I'll put the other ones with exponents, I'll put those next to each other, which will allow me to use my exponent rules. And the first thing I'm going to do is I'm going to do 1.56 times 4.03. And I'm actually going to do that in my calculator because I don't want to waste time with multiplication algorithms when really what we're focusing on is exponent rules. So when I multiply those two things together, I get 6.2868. Okay, and then what I want to do is simplify this as much as possible, and I know that I have the same base, and I have two different powers, and I'm multiplying them together, so which means I need to add the exponents. So I've got times 10, 14 plus 3 is 17. Now it says to write your answer in scientific notation, so we have to make sure that this number here is between 1 and 10, and that off to the right we've got a power of 10. Well, both requirements are true, so this will be our answer. So I'm just going to erase some of that extra notation so that my work is easy to read. Put a nice little box around this. In fact, I can make it a perfect box by using this little feature. Okay. And it cuts off a little bit, but that's okay with me. So now we're going to scoot down and we're going to do the same thing for the Atlantic because there's one more step here that's going to be important for us to know about. So let's head to the Atlantic again. I'm going to undo that, and I want to switch it to just a regular old pen. In the Atlantic, okay, I'm going to skip step 1 since you've already seen it. Okay, I'm going to start with just combining my non-exponent terms. 7.68 times 3.93. Okay, and then we're going to multiply that by the other two terms, times 10 to the 13th, times 10 to the 3rd. Okay, and just like before, I'm going to use my calculator, so I'm literally typing in 7.68 times 3.93, and that's giving me 30. We'll go back to orange. 30.1824. Okay, then I'm going to do the right-hand side, and that's going to give me times 10 to the, I got to add my exponents, 13 plus 3 is 16. And it seems like I'm done, except for the fact that it asks me to write my final answer in scientific notation. That's going to be a problem because notice that this 30.1824 is not a number that's between 1 and 10. But fortunately, we can adjust for this. So what we're going to do is move the decimal point back one place. Okay, and I'm going to scroll down just a hair so I have more real estate to work with. So I have 0.1824. Okay, and what I did was I divided by 10. So in order to undo that division by 10, I want you to think about some strategies. Think about inverse operations and how we could make up for that later. Well, one way to undo dividing by 10 is to multiply by 10. So I'm going to head up here to the second to last step, and I'm going to multiply by 10, which is secretly 10 to the first power. And that means that to compensate for that little decimal place scoot, I've got to now add these exponents. 16 plus 1 is 17, so we're going to get times 10 to the 17th. And that is how we can make sure that our final answer is in scientific notation. It's really important to think about whether you are moving the decimal point left or right. Right is going to multiply it by 10, left is going to divide by 10. So whichever one you do on the left-hand side, you have to make sure you compensate for it in the other direction on the right-hand side with that exponent. So really be mindful and thoughtful of that. So with that said, you've now seen 2 of those 4 done for you. you have an answer key. And hopefully, now that you've seen two of them, you can figure out the third and the fourth because the algorithms are exactly the same. With that said, I hope that this was able to give you some insight into how exponents can be used to understand and apply to lots of different problems. If you have any questions on what I went over, or if you have any concerns coming up about the test, please feel free to send me an email, and I'll be happy to help you. So thanks so much for tuning in.